Hi everybody, the channel Knowledge Academy welcomes you. In this video we are going to discuss about the basic functional unit of sequential circuit. Yes, flip-flop. Already I have posted a video on the same topic in my mother tongue Tamil. Now let us discuss it in English. So before entering into the video, subscribe my channel Knowledge Academy. Now let us go for further discussion. So what is meant by flip-flop? Flip-flop is the basic functional unit of sequential circuit as I mentioned, and it is a 1-bit storage device. It stores either 0 or 1. Okay. Now, whenever we talk about flip-flop, there are different types of flip-flop like SR, JK, D, and T flip-flop. We are going to discuss all those flip-flops in this video, and there is another thing called latch, so which also has the same types as that of flip-flop. Okay, SR, D, T, JK, and T latches are there. So what makes the difference between latch and flip-flop? Latch also produces the same output as that of flip-flop, but the thing is, the main difference between latch and flip-flop is in the control unit. Okay, so what controls latch? Latch is controlled by an enable signal. Okay, so here enable signal means it is not required for the enable signal to be switched between high and low at constant time interval. It can change between high and low at any time interval. Okay, any time interval. Okay, so it is not required for it to be to maintain a constant time interval. Okay, so here it is maintained for a bit duration for a certain time interval, and here the duration is different. Here the duration is again different. Okay, so here what happens, this latch checks for the enable signal. So whenever the enable signal is high, okay, it changes its value. If it changes its value in the sense, it produces the output for the corresponding input only when the enable signal is high. Okay, so that means this latch is level trigger. It is level trigger. Okay, so here level. Okay, so positive level or negative level. Okay, so either it can be enabled whenever the enable signal is high, or whenever the enable signal is low, depending upon the design. Okay, so this is regarding the latch. Okay, it is not easily controllable, and it produces output whenever the enable signal is high, and it is level triggered. So it makes the latch not usable in circuits as that of flip-flops. Okay, so whereas flip-flops it is it is not level triggered. Flip-flop is edge triggered. Okay, and we are not giving any enable signal as the controlling unit. Instead of enable signal, we are giving a clock pulse, and the clock pulse is the higher value, and the lower value of the clock pulse is maintained for the fixed time interval. Okay, so here this is a fixed time interval, and the duration between this point and this point is also fixed. Okay, so it maintains the constant time interval throughout. Okay, and as I mentioned earlier, it is not level triggered, it is edge triggered. Edge triggered means when the clock pulse changes from negative value to positive value, or when the clock pulse changes from positive value to negative value, it changes the output. So when the flip-flop changes its output for the corresponding input, when the clock pulse changes from positive or negative value to positive value, means we call it as positive edge triggered. So this one, when if the flip-flop changes value, if the flip-flop changes its value during the rise of a clock pulse, so this point. Okay, so this point we call it as positive edge triggered. Okay, if the flip-flop changes its value during this point, when the clock pulse changes from a positive pulse to or positive value to negative value, positive amplitude to negative value at this point, okay, we call it as negative edge triggered. Okay, so at this instant the flip-flop produces the output for the corresponding input. Okay, either positive edge triggered or negative edge triggered, depending upon the design. Okay, now let us discuss each and every flip-flop one by one. Okay, the basic and the foremost type of flip-flop is SR flip-flop. Okay, so there is an acronym for S and R. S we call it as set, and R we call it as reset. Okay, so we can consider this as two switches. Okay, set switch and reset switch. Okay, what happens when we press set switch? We are setting the system. Okay, so setting means we are giving some value. Okay, it takes some value. Okay, and resetting means we are pressing the switch. Reset means the system is reset to initial condition. Okay, so here the thing is, when we press the switch set, flip-flop takes the value 1, and when we press the switch reset, it takes the value 0. So this is the main idea here. Okay, so set means we are setting the value, okay, setting the value to 1, and R means reset, so which means we are resetting the flip-flop to 0. Okay, so this is the main thing. If we have a clarity on this, all the flip-flops become very easy. Definitely in this video you can understand all the types of flip-flops very easily. You don't have to memorize, and it will be very easy to understand. Okay, it is easily understandable, right? So here let us look at the first condition, and as I mentioned earlier, flip-flop is a single bit storage device. So here what happens, we use flip-flop in a sequential circuit whose output depends not only on the current input or also at the previous output. So here Q of n plus 1 is the current state, I mean next state, which is the desired output of the flip-flop, and this output of the flip-flop depends on three things: the present inputs of flip-flop, and also the previous state of the flip-flop. Okay, that is Q of n. So Q of n plus 1 depends on the inputs S and R of flip-flop, of SR flip-flop, and also the previous state Q of n of Qn of flip-flop, right? So here S is 0, R is 0. Okay, so that means we are not pressing any of the switch. We are not pressing both set switch and also reset switch. We are not pressing any of the switch. We are not disturbing the flip-flop. Okay, so that what happens to the output of flip-flop? Okay, so output of flip-flop maintains its previous state. Okay, so if the previous state was 0, it maintains the previous state here also. It is 0. If the previous state was 1, it maintains that previous state here. It is at 1. Okay, so this happens when we do not press any of the switches, any set switch or reset switch. Now let us look into the next condition. Okay, so the next condition is S is 0, R is 1. So S 0, R 1. Okay, that means we are not pressing the switch set, but we are pressing the reset switch. Okay, reset switch is pressed. Okay, when we press reset switch, what happens? The system is reset to 0. Okay, so Qn is, whether it is 0 or 1, Q of n plus 1 doesn't worry about Q of n. It takes the value 0 by force. Okay, it is reset. It is reset to 0. Okay, by force. We are forcing it to become 0, right? Now the next one, here S is 1 and R is 0. Okay, so we are pressing the switch set and we are not pressing the switch reset. We are not pressing it. Okay, so here what happens, whatever the previous state of the flip-flop could be, okay, it could be either 0 or 1, but the present state becomes 1. Okay, we are setting the flip-flop. We are forcing the flip-flop to take the value 1. Okay, we are setting it when we press a set switch. Okay, so this is the thing. Now the next one is 1 1. Okay, we are pressing set switch, we are pressing reset switch at the same time. We are pressing set switch, reset switch. You are pressing both the switches at the same time. So what happens to the flip-flop? It confuses. Okay, so it is not in a stable state. It confuses what value to take. Okay, whether 0 or 1. Okay, so what happens? So whatever the previous value could be, this current state, the output or the required output of the flip-flop, it switches between 0 and 1. Okay, it does not take any constant value. It is in an unstable state. The value 0 and 1 compete with each other to take the output of flip-flop. Okay, to be the output of flip-flop. So there is a competition prevailing here. So flip-flop is not in a stable state. So we call this condition as undefined. Okay, so this is one of the disadvantages of SR flip-flop. Okay, so this condition is called as undefined. Now next we shall derive the Boolean expression for SR flip-flop. The SR flip-flop, the desired output is Q of n plus 1, and this Q of n plus 1 depends on three things. Two inputs and one previous state. So on these three things it depends, Q of n plus 1. So we have to draw a K-map of 4 cross 2 or 2 cross 4. So 3 values, it depends on 3 values, means 2 power 3 equal to 8. So 8 boxes should be there in K-map. Okay, and these 8 boxes can be drawn in any form, either 4 cross 2 or 2 cross 4. Here I have drawn as 4 cross 2 K map, 4 cross 2 K map. I'm going to fill the values of Q of n plus 1 inside the K map depending upon the value of S, R and Q n. Okay, so here I'm going to again fill the same truth table here. S, R here, S, R both are 0. So when Q of n1, Q of n is 1, Q of n plus 1 is 1. Okay, and here yes, S is 1 and R is 0. That means I'm I'm pressing this switch set. So what happens, whatever the value of Q of n be, 0 or 1, Q of n plus 1 is 1. So I'm filling it here, and here 1 1 Q of n and sorry, I'm pressing both the switches S and R, and we call it as an undefined state. So undefined state is marked as don't care condition inside the K map. Now I have to go for grouping. So grouping is done in the form of 2 power n number of ones. Okay, so here maximum of 2 power n number of ones that can be grouped is 2 power 2 equal to 4 number of ones. So these 4 boxes can be grouped together. Okay, so 4 boxes can be grouped together, and I have to derive the Boolean expression for this group. Okay, so while I look at the value of Q of n takes both 0 and 1, so it can be neglected. And when I look at the value of S and R here, SR takes 1 1 and 1 0. So this is for S, this is for R. R takes both 1 and 0, so it can be neglected. Only S is prevailing, and the value of S is 1, so I am writing S here. Okay, now I'm moving to another group. So I am introducing one plus symbol here, and another group is, so this one is alone, this one is alone. So I have to look for the possible ways by which it can be grouped with another one. So here this one can be grouped with this one. When I fold this K map in the like this, if it is in the form of a folding paper, this one can combine with this one. Okay, they become together, they come very close to each other, and they can be grouped, they can form a group. Okay, 1 1, and I have to derive the Boolean expression for this one, and for this group the value of Q of n is 1. Okay, and I have to look at the value of S and R. S R here. Okay, so S R, it takes 0 0 and 1 0. So this is for S, this is for R. S takes both 0 and 1, so S is neglected, whereas R takes only 0. So R is the condition of the switch reset is reset bar, R bar. Okay, so R bar Q1, I have to write it as R bar Q1. This is the Boolean expression for SR flip-flop, S plus R bar Q1. Okay, so can I draw a circuit like this? Yes, sorry, yes, R, and when I introduce NOT gate, this becomes R bar. So yes here, and Q1, another one input. Okay, so this AND gate, so output of this AND gate is R bar Q1 and an OR gate, and here it becomes S plus. Can I draw a circuit like this? No, it is a big blunder. So we should not draw a circuit like this, because here Qn is not an input, it is the previous state of the entire flip-flop. Okay, so we should not draw a circuit like this. The Boolean expression is defined like this, but we should not draw a circuit like this. If we draw a circuit like this, it becomes a combinational circuit. Okay, so here Qn is not an input, it is the previous state. So here this is the kind of circuit that has to be drawn for that defines the value of SR flip-flop. Here it can be drawn by using either NOR gate or NAND gate. Here I am using NAND gate, and here this one we call as latch, and here the latch is controlled by this portion, and if I use an enable signal here, it becomes SR latch. Okay, but here I am using a clock pulse. So this is the circuit for SR flip-flop. Here Q of n plus 1, here Q of n plus 1 bar is produced, the complement of Q of n plus 1, and here yes, reset, set and reset, these are the two inputs. Okay, depending upon the previous value of Q of n, depending upon the previous value of SR flip-flop, it produces the current value Q of n plus 1. Okay, this is regarding SR flip-flop, and this was the symbolic representation of SR flip-flop. Okay, symbolic representation. There are 5 pins, S, R, and clock pulse. So they are the inputs, they are at the input side, and in the output side we have q of n plus 1, and the complement of q of n plus 1, that is q of n plus 1 bar. Okay, so this is regarding SR flip-flop. Now let us move into another flip-flop, D flip-flop. Okay, so the main difference between SR flip-flop and D flip-flop is what happens in SR flip-flop. There was a disadvantage. Okay, an undefined state was prevailing. Okay, when we press both set switch and reset switch, the output, okay, the output of SR flip-flop, it is not at a fixed value. There is a confusion prevailing, and it is an unstable state. Both 0 and 1 compete with each other to climb the output of SR flip-flop. Okay, so in order to avoid the condition, researchers were done, and from SR flip-flop, what happened, a small modification was done in order to avoid that condition. Okay, S and R are connected together through a NOT gate, and a single output was taken, and the output was named as D. Okay, so when D is 0, it is similar to S taking 0 and R taking 1. When D is 1, it is similar to the condition S taking 1 and R taking 0. Okay, so 1 0, so like that. Okay, so it produces the output of output when S was 0 and R was 1, or when S was 1 and R was 0. Okay, so that becomes another flip-flop called D flip-flop, or delay flip-flop. D means delay. Now we shall understand what this delay means. Okay, right. Now D is 0. So D is 0 in the sense, when we compare this to SR flip-flop, S is taking 0 and R is taking 1. Okay, so S is taking 0, R is taking 1 means, so we are pressing the reset switch, we are resetting the flip-flop to 0. Okay, now, so whatever the previous value could be. Okay, so it doesn't worry about q of n plus 1, doesn't worry about the previous state q of n, it produces the output 0. Okay, right. Now next, when we give the input D as 1, okay, so when D is 1, S is taking 1 and R is taking 0, that means we are pressing this switch set, so the output of flip-flop is set to 1, right? So whatever the previous value could be. So what happens now, let us analyze the input and the state of the flip-flop. Here our input is 0, here input is 0, and the output of flip-flop is also 0. Here the input is 1, output of flip-flop is also 1. So that means, can we join, is it a single line? No, it is not like that. Okay, since it is a flip-flop, and the flip-flop, it depends on the previous value also. Okay, previous state also. So what happens, since the same output is maintained, since the input which is given to the flip-flop is comes as the output, but at a delayed clock pulse. Okay, delayed clock pulse, we call it as a delay flip-flop. Okay, for example, so we are giving input to 0, input as 0. Okay, so what happens initially, let us assume that the state of the flip-flop was at 1. Okay, and now we are giving an input as 0. Okay, so immediately this flip-flop does not produce 0. Okay, what happens, we have to press the clock pulse. Only if the clock pulse is pressed, and in the edge triggering portion, it is changing its value, and it maintains that value. Okay, right. So if you do not press that clock pulse, okay, if you do not activate that clock pulse, this input does not have any impact on the output of flip-flop. Okay, output is maintained at the previous state only. Okay, similarly, now 0 is available on the flip-flop, but we are giving an input as 1 to the D flip-flop, so immediately it does not change its value to 1. Okay, it waits for the clock pulse. When the clock pulse is activated, it makes its value as 1. Okay, so a delayed value is present. Okay, so whatever the input we give, it appears at the output, but at a delayed time period. Okay, so that is why we call D flip-flop as delay flip-flop, right? So this is regarding delay flip-flop. And here we are deriving the Boolean expression. So when D is 1, it is 1. Okay, and here this can form a group, and the value of Q of n is taking for this group, it is taking both 0 and 1. So Qn is neglected, and the value of D is 1 here. So Q of n plus 1 is equal to D. So this is the Boolean expression for D flip-flop. And here is the circuit of D flip-flop. It is similar to SR flip-flop. So S was here, R was here, both are combined together using NOT gate, as I mentioned earlier. Okay, so this is regarding the circuit of D flip-flop. Now this is the symbolic representation of D flip-flop. Since only one input is here, D, so that is D. Another one activating signal is clock pulse. This is the output Q of n plus 1. This is the complement of output Q of n plus 1. Okay, so that is Q of n plus 1 bar. Okay, now let us discuss about JK flip-flop. Now what happens in D flip-flop, the condition was avoided, but a solution was not given to the disadvantage of SR flip-flop. What is the disadvantage that SR flip-flop had? When both S and R are 1, it is in an unstable state. So that condition, that thing is not solved, but the thing is avoided in delay flip-flop. So again, researches were done, and Jack Kilby, this one person, Jack Kilby, he came out with the solution for that problem, for that unstable condition. Okay, so here, what was that problem? So remaining things of SR flip-flop comes the same as same in JK flip-flop. So Jack Kilby, JACK, Jack Kilby, and he is Nobel Prize winner. So here, this person Jack Kilby, he designed a flip-flop, and by his name it is called as JK. Okay, and J is analogous to S of SR flip-flop, and K is analogous to R of SR flip-flop. So J means set and K means reset, jump and keep. Okay, set and reset. Okay, so here all the conditions are similar to SR flip-flop. Okay, when when both JK are 0, that means SR, both set and reset are 0. You're not pressing any of the switches set and reset, it is maintaining its previous state. Okay, and here the next condition, when K is 1, that is we are pressing the switch reset, it is reset to 0. Okay, and when J is 1, we are pressing the switch set, it is set to 1. Okay, set to 1. Now the important condition comes here. When both the switches are pressed, when JK is pressed, both set and reset are pressed, it toggles. Toggles means it gives a complement of previous state. Okay, when previous state was 1, it produces output 1. When previous state was 1, it produces output 0. Okay, so when previous state was 0, it produces 1. When previous state was 1, it produces 0 as the output. Okay, it complements, it toggles its value. Okay, when we press both the switch. So in this manner, the disadvantage of SR flip-flop is overcome. Okay, in JK flip-flop. So let us derive the Boolean expression for this. So this is the Boolean expression. Initially in SR flip-flop, we had X and X here. Okay, but here when both the switches are pressed, what happens? When the previous state was 0, it gives 1. So that is the only thing. Okay, now we have to go for grouping. And when we group, so these two ones form one group and these two ones form another group, and the Boolean expression that we derive here is JQN bar plus K bar Qn. Okay, and this is the circuit of JK flip-flop. The only thing is, from the output, okay, from this output, a feedback loop is taken, a feedback line is taken, and it is given as the input to J, and from this a feedback line is taken, and it is given as the input to K. Okay, so this is the only thing that makes the change between SR flip-flop and JK flip-flop, feedback line. Okay, so here from this point it is given as the input to this NAND gate and also to this NAND gate, and here from this point it is given as the input to this NAND gate and also to this NAND gate. Okay, to K. Okay, right. So this is regarding JK flip-flop, and this is the symbolic representation of JK flip-flop. Okay, now comes T flip-flop. So what happens, so this is we can derive T flip-flop from JK flip-flop. So J is here, these two pins J and K, they are connected together, okay, and they are taken as a common pin. Okay, that means and a name is designated for this pin as T. So when T is 0, both J is 0 and K is 0, it produces the output for this condition. When J is 0, K is 0 means when S is 0, R is 0, set is 0, reset is 0. So Q of n plus 1 is maintaining its previous value. Okay, so this is one thing. Then when T is 1, it is analogous to both J is 1 and K is 1. Both J and K of JK flip-flop are 1. So 1 means Q of n plus 1, it toggles. Q of n plus 1 toggles the previous state. If previous state was 0, it produces output 1. If previous state was 1, it produces the output 0. So we call this one as T flip-flop or toggle flip-flop. So look at the truth table. So 0 means both J and K both are 0 0. It is maintaining its previous value. 0 means here also 0, 1 means here also 1. Okay, now 1. So when T is 1, J, K both are 1 1. So it is toggling. When previous state was 0, current state is 1. When previous state was 1, current state is 0. So toggling. So this is regarding toggle flip-flop, and this is the Boolean expression for toggle flip-flop. Here we had J bar, okay, here we had K in JK flip-flop. It is replaced as by T. J and K, they are replaced by T. We are getting T bar Q1 plus T Q1 bar. It doesn't mean that it is T XR Q1, so we should not write like this. It is not a combinational circuit. Q1 is the previous state and it is not an input. Okay, so that the Boolean expression is T bar Q1 plus T Q1 bar, and the circuit, this is the circuit. Okay, so we are joining J and K of JK flip-flop. We are joining them together, and a single lead is taken, that is taken as T. Okay, so this is the circuit of T flip-flop. And the next one is, this is the symbolic representation of T flip-flop. Only one input is available, and this is the control signal, controlling clock pulse signal, activating clock pulse signal, and this is the output of T flip-flop, Q of n plus 1, complement of output Q of n plus 1 bar. Okay, so this is regarding all the flip-flops. So I hope you understand how we can derive all the flip-flops from SR flip-flop. The basic understanding of SR flip-flop is required. So in order to avoid the disadvantage that arise in SR flip-flop, all the other flip-flops were designed. Okay, from SR flip-flop, D flip-flop arrived. So from that JK flip-flop arrived, from that T flip-flop arrived. So this is the sequence of arrival, and this is the sequence of understanding all the flip-flops. I hope this video may help you to understand the things related to flip-flop. If you like this video, kindly comment, share, and like this video. Don't forget to subscribe my channel Knowledge Academy. Meet you again in a next video, in another video. Until then, bye. Thank you.